This is a list of spontaneous questions that we came up with, which Saul has seen. Spontaneously answering, right? Dr. Perlmutter, you have had an incredible career as a scientist. If you were to identify 3 of the most important qualities that a scientist should bring to his or her work, which 3 would you single out?
Okay. Well, first, I should say good morning to everybody, and I will begin by just commenting that in my family it's a standing joke that my wife and daughter love doing lists of things, and that I can never come up with anything when asked to do a list. However, in this case, I think I actually realized that a couple of things did come to mind.
They told me you'd probably answer this one,
which is rare, you know. So I was thinking that probably the one that would immediately spring to people's mind about a quality for a scientist would be curiosity. But I realized that I think there's a really specific kind of curiosity that you're really looking for in a scientist, which is a certain kind of curiosity that focuses in on a problem that feels, not among all the things we're curious about, the ones that actually feel like if you got the answer, it would be very exciting, and that they're actually doable, that there's a possibility to get this answer. So the ability to focus in, I think, among all your curiosities to something that has that kind of meaning and possibility is one. Second one that came to mind was the comfort with uncertainty and ambiguity, and that leads you to be able to change your mind. And in fact, the pleasure in figuring out when you discovered that you misunderstood something, or you got something wrong. And I think that this is something that is maybe not typical, that most people will immediately enjoy it when they find out that they were wrong, but that is something that you actually want in a scientist, because you want them to be hunting for where the mistakes are in just what they're doing day to day, but also in the big picture of what do we misunderstand about the world. Yeah. And then the third one that was coming to my mind is this ability to pick up this culture of science that allows you to be unrealistically optimistic. Because almost any problem that's worth its salt can't really be solved in the ordinary time frame of most humans, and that you need this to borrow from this culture, this ability to stick with things way longer than most people would stick with it, which is, of course, the answer. Part of what was going on with that when Carl came to that poster back when, that we thought it was going to be a 3-year project to find these supernovae. By the time I think I saw him, we had been working for 3.5 years, and we knew that we needed to find 30 supernovae, and we would do it in 3 years. It was 3.5 years in, we had 0 supernova. But we actually had figured out how to find the supernova, and then after we had one, then we had figured out a way to find batches, and et cetera. Mm-hmm. Finally, I would just throw in an extra 4th for free, since it's not 3. And the 4th one that came to mind was somehow or other, whether you're an introvert or an extrovert, I think scientists have to be social. They've got to figure out how to network in with other scientists so that they just can learn and build on each other. And maybe the networking is a conflict-style network. Some people are just pugnacious and they'll fight with everybody, but they connect. And I think that connection, others are warm and they manage to build a group of family of people who are working together. But whatever it is, that connection is, I think, a huge social aspect. Is a huge part of science.
I love your list of 4. Can I go back to the second one? Is that a quality of mind, like being willing to be wrong, that can be developed outside of science? Could a historian have that, or, God forbid, a philosopher like myself?
So we here at Berkeley, in fact, we've been developing over the last 10 years or so a course that's called Sense and Sensibility in Science, which is essentially a scientific style critical thinking course, but we're teaching it with a philosopher and a social psychologist. And one of the big running themes through it is this idea of learning all the different ways that we tend to fool ourselves, and then trying to be very open to looking for how we're fooling ourselves this time and what new way we've invented to fool ourselves. Mm-hmm. And that's actually a lot of what science is built on. Yeah. And I think that apparently it's teachable. The students start to get the story fairly well. Yeah.
As a philosopher, I'd like to say that same mindset is equally as important for us to do our work well. Just as not all scientists have this quality, as we know, many philosophers don't as well. But it's fascinating to see. Go ahead.
No,
I can be as loud as you want, so if that's what you want. So people in this room are well aware of the discovery that you, Brian Schmidt, and Adam Rees made, for which you won the Nobel Prize. People know the role that your discovery, that the expansion of the universe is accelerating, played in the development of the theory of dark energy. So we would like to instead ask you to step back and to share with us your thoughts about some of the broader implications of your discovery as you understand them. What, for example, might it tell us about the origin of our universe or its final destiny?
So the interesting thing about this particular discovery is that it was a discovery with a kick, which is that it led to a new mystery immediately. So because there's so many things wrong with the idea the universe is accelerating, it means that you are forced to have to think about different ideas that of different ways in which we may have gotten our picture of the universe a little bit wrong. It could be something very simple. It could just be that empty space has some energy associated with it, and that was what Einstein might have called the cosmological constant. But there's a huge variety of other options, and in fact, at one point I think I was estimating that there was a scientific paper published every 24 hours with a different theory and this went on for 10, 15 years, and I think it's still today you might find that the number is something of that sort. So it is opening up a mystery, but that means that when we ask what the implications are, for example, for the fate of the universe, the answer is it made our understanding of the fate of the universe that much weaker. That we now have to figure out first, why is the universe doing this acceleration thing? Because that right now is likely, whatever it is, to determine what the future properties will be. If it turns out to be this Einstein's cosmological constant, then you get this expansion forever. But if it turns out to be a decaying scalar field, like a new Higgs field, then it could turn around and the universe could come to a halt in the end and collapse. So it's basically opened up the options in some ways rather than narrowing in this particular case. Working back in time, of course, what you're trying to do with origins is you're trying to understand more and more what are the basic constituents. And if we get this constituent clearer, then it seems like an important part of the puzzle, because we think right now that it's probably most of the universe is made out of this dark energy, if that interpretation turns out to be correct. So it's obviously going to be pretty important to get straight what it's doing if we're trying to work way backwards to understand where things get to.
Yeah, I've heard you do other interviews speculating on the initial rapid expansion of the universe and dark energy, which is a technical field that I'd love to go into with you, but maybe not today. So that leads naturally to the next question. You're the opening speaker in a Berkeley conference with the title Science and Philosophy, a Unified Pursuit, ? Which I like. How do you think that science and philosophy work together? So diving right into the title. So yeah, let's just start there, just to stop there.
Well, I will say that for me, one of the real driving impetuses to do science is the philosophical implications. That I just happen to be one of these people who was always pulled into it that way, and that I was most interested in the elements of science which seem, to force you to rethink about, what does this universe consist of, and how does this all work, and in particular to be forced to think that the world is not at all what we think what our brains naively imagine. When we discover that, special relativity tells us that space and time are weirdly intermixed. This is the kind of thing which is deeply, deeply philosophical, and yet I can't imagine any philosopher ever having thought that space and time are similar objects and they actually could be traded off against each other. I think that it just wouldn't have occurred to anybody until you actually start to see that the universe was behaving this way and the world is behaving this way, and you're forced to rethink what does this reality consist of that we live in. So I think that there's this very deep connection available to us. I should comment that, of course, that there is a lot of other science, which is the science of, you could almost think of it as like, what are all the Rube Goldberg connections that make things happen? I mean, and a lot of what goes on in the human body, for example, if you're trying to study biology or something like that, is a very Rube Goldberg connection, and you're trying to figure out what are all the links that occur. For many people, that's actually a really compelling science. It just happens not to trigger me in the same way, but it's maybe even the more useful in many cases. It's often the way that we actually figure out how to do things in the world. So I think science has various different ways to come into it. The one that happened to grab me was the philosophical.
Possible follow-up question. In the interviews, I've watched a number where you're asked very philosophical questions, leading questions, and I watch you sort of accepting the invitation, exploring it a little bit, and saying, but here are the numbers that I know, or here what I know about the theories. Whereas the philosopher in the similar interviews will say, oh, that's fascinating, let's look at these other possibilities. Is that a fundamental difference, a difference in temperament, or you're just being polite because they're representing physics?
I think and I'm sure that there's many, many different styles of philosophy and of philosophers. I think the part that you may be picking up when I'm talking is that I'm often in the position of being asked, what do we get from these particular science results that we can then take back to what is an ongoing discussion that's already been going on for many, many, well, often centuries. And I'm trying to be a little bit careful because I don't want to overinterpret. That there's often a tendency to say, quantum mechanics has an indeterminacy built into it, and therefore, doesn't that explain free will, or something like that? And my feeling is, there's often a bit of a leap that's being taken because somebody already has a predisposition or a picture of the philosophical framework that they're currently working in, and it's too easy to make that leap. And I'm often trying to sort of hold back and say, let's not rush there. Let's try to see, is this really the only possible conclusion of this new scientific result, or should we consider that there's a wide variety of possible conclusions, and that so we don't take this as evidence for this theory versus that theory if it's not the best.
What if we could pluralize philosophy so that rather than a gotcha moment where people say, okay, now we know there's free will and that's settled and let's keep going, where we said, let's explore this. So physics or some science points in this direction. Let's see what a theory like that would look like, but hypothetically. Then let's go back and look for more evidence or do a better job with theory construction.
That's very much more in the lines of what I enjoy, what I like to see. I mean, I think a great example. Well, it's probably slow right now that the theory of that philosophy is providing us the right, very helpful questions for physics, but it's great when it does. But it's right now. I think it's hard to do, just because of where we are in physics and philosophy. But in other areas, like I would be almost equally interested, or maybe equally interested. I considered switching fields from physics to cognitive science when I was a postdoc, because I had a great undergraduate course in cognitive science. I then followed it for years and years. Went to every seminar, every week. So I think the mysteries of how the mind works and how can be as exciting as how the world works. And there's a field where I feel like the interaction of the philosophy and the science is much more necessary, because it's very hard to parse what question are you really trying to ask, and what would make a good experiment. And I think the philosophy can help a lot, because it's very good at helping sharpen the question and figure out, okay, what is it that we're really asking? And then an experiment can be done that I think would be wonderful way of moving back and forth, which happens, by the way, just for the fun of it, I should mention that my daughter happened to go into this, and she just started graduate school in a group that has both a philosopher and a cognitive scientist leading it. So I keep watching and think, wow, I would join that group.
We were here in the faculty center some years ago, and Andre Linda said, well, people talk about my cosmological work, but when I was in Russia, I developed a theory of consciousness that I actually think was more important and more significant, which is not widely known. I probably shouldn't have told the story.
Didn't know.
So let's talk about what some might see as the hardest area, but maybe you wouldn't. Metaphysical reflections by philosophers, what might be fundamental reality, has often served as stimulus for scientists through the centuries. the people who used to be called natural philosophers. So what are your views on how metaphysical speculations might serve as the soil for new scientific hypotheses to test?
So in some extent, I've jumped the gun on that question with this example from cognitive science, where it does feel to me like there's it's much more obvious that if you want to say, an example would be, what is it that consciousness, when people ask about what is, is there something that's consciousness and what is it made out of, what does it consist of? It seems to me that a good philosophical job is to start helping us parse the many, many different things we mean by consciousness, so that we aren't trying to ask experimental questions of this soup of ideas, when clearly consciousness, sometimes we're talking about is it the ability to respond to the world that we see around us in self-motivated ways, but that could be done sleepwalking. And the question is consciousness, does it have to not be sleepwalking? And you can imagine that and that's just one example where you start to try to separate out, okay, by consciousness we probably mean this, and we also mean this, and we also mean this, and each one of those should be experimented with differently. Yeah, I think I'm trying to remember examples where the same thing happened in physics. And it's harder, because I think in many, and it's probably because I'm not going far enough back where we had to actually parse out, what do we mean by motion, and what do we mean by, and how do you tell if time is actually something that is acting as a rhythm behind everything. And those are all things that we take so for granted now that I almost don't see it anymore. Mm-hmm. But I imagine that was actually something that was very helpful when, like, Newton and Leibniz and all the others were trying to formulate their original pictures.
Yeah, so that's where my research is, and actually there were constant discussions back and forth with stimulus from the philosophical side, tested, and those new results became fertile soil for the philosophy work. In an interview with Kuhn, Robert Lawrence Kuhn, on Closer to Truth, there was a moment, and what you just said makes me think of it, where the topic was, why did our universe begin? And you said, well, one can give the best that physics says. Imagine that we have equations that tell us that, and you said, some people wouldn't be satisfied with that, but I'm kind of drawn to that. And there was an opening there where there was something like, yeah, but also there are other questions about the beginning of a universe than that. In other words, you implied that in some ways the numbers alone wouldn't be in the end satisfying. And I wanted to probe where he didn't probe you at that moment. Is that too personal?
No, absolutely. So the conversation that we're talking about was one where I was being asked, why did the universe begin? And we worked our way backwards towards it, because I was saying, well, what we really do with cosmology is a little more of a how did the universe get to where it is, and we start working our way from what we know and we see today to what would get you to this particular current scene, what would get that to trigger, and can we work our way back to what is actually the causal connections to what is the simplest picture of the very, very earliest story, and that by itself, of course, isn't a why. That's all a how, in some sense. The only thing that I think is, we all have the sense that if you really, really were able to work the whys back to a very, very elegantly simple picture, maybe that would lead you to start to suspect a why, if you had done that. I think that's sort of in the back of our minds, when we're doing this. On the other hand, you could say, well, suppose what you end up with is a very, very elegantly simple picture of the universe, which of course is what physics is all about, right? Usually, right? It's trying to say there are many, many things that could all be going on, but actually they all are explainable by a relatively simple part of the story. And you could imagine that if this all kept working, you'd eventually get back to a very, very, very early version of cosmology of the very first moments, where you almost don't have to describe anything. All you need is like a single equation. And if that equation turned out to be true, then everything else would follow. And that is obviously sort of like the picture of what it is that you're trying to do in some sense as part of this physics effort, that we're describing. The problem is that I think when you sit back and you say, okay, it all worked. We got this equation. If you have this equation, then the world holds. In fact, you could even say, maybe mathematically, for some reason or other, this is the only equation you could get. That's it. I mean, and this is, I'm now just being, imagining the ideal picture, which I don't really think is what we'll get, but suppose that were to happen. Even so, it doesn't necessarily give you a why, because it doesn't answer the question of why is there an equation as opposed to no equation.
Yep.
And so I'm suspecting that then when you go one step further and you say, okay, it doesn't do the answer that I was hoping for, I think that the question I find myself now posing when I talk to people about this is, what would be a satisfying answer to anything of this sort? It's hard to imagine what would count as a satisfying answer, because the traditional, and since we're in a discussion where religion is also part of the discussion, a traditional answer could be saying like, well, the answer is there is a deity, and the deity chose that equation. But from the point of view of this style of questioning, that doesn't answer anything, right? All it does is it labels the puzzle with a name. We call it, it would be the deity. But it doesn't say, was there any? Did deity have another choice? Could they have written down a different equation? I mean, you still have all the same questions would still arise, in that scenario. So that's why I think it's kind of a very fundamentally philosophical return to that question, because you can't avoid the fact that you have to figure out what counts as a satisfying answer.
I have a follow-up question for you. When I prepare the movie, I make a pre-interview with Andrei Vilenkin in Tufts University in Boston. And sadly, when we came back to film him, he had a stroke and he was not able to speak. So he was not in the movie. But when I make the pre-interview, not a video orally, he told me that because of the Guth-Bord-Vilenkin theorem, for him it was sure that there is a beginning to the universe or to the universes, if there are many universes before the Big Bang. So my question to you is, for you, what you think is there's an absolute beginning to the universe, and so, as you say, of space and time, because space and time are completely linked, as we know, or is there an absolute beginning of universes in the past? What is your position compared to the Vilenkin position?
So there are a variety of ways that people have approached sort of describing the start of the universe, and there's this discussion about, is it possible that that the beginning of the universe is also the beginning of time in and since we now know that time and space can be traded against each other in special relativity, isn't it possible that what we're really seeing is, in some odd way, you're making your way back in time, working up toward the picture that people use is you're working your way back on a globe towards the North Pole, and that you're going up in space, but actually time is also implicated, so that when you reach the North Pole, there's no further you can go. That just happens to be the beginning of the whole thing. That's when time started, and there's nothing more magical about it than something magical about reaching the North Pole and all the lines of latitude, converging, at that point. And I think that may actually be a very plausible answer to the question. And there are, of course, other versions of the theories that are floating around where you constantly create new universes. And so within any universe, there are moments of, and possibly infinite moments of instability of a little local area of that universe, and there's a baby universe that ignites from that particular spot. And so there's an infinite number of constantly bubbling new universes forming out of the previous universes. And in which case, it's an example of theories in which it could be continuous, it could be forever, that you go back in time and there's always a continuous creation of universes out of other universes, and it's turtles all the way down. There's no end to this. From my point of view, when asked, what do I think, I find myself very much in the in the position as a experimentalist, as an observer, observational cosmologist, that I love to collect the theories, and I love not to have to put my weight on any one or the other. Mostly, I'm hunting for, is there something you could measure that would distinguish whether we're in this situation or in that situation? And that's where my pleasure goes. And I kind of like the fact that I can play, agnostic, arbiter for that moment among the theories, if I happen to find a good measurement that would tell them apart. So maybe that's the closest to my answer.
Just one point about the infinite. Is there's not some scientific problem with infinite in the past? Because there's some theory saying that if there's infinite in the past, you have the bouncing effect, and the universe today must have been very different than the universe we observe if there was infinite number of universes in the past and this sort of thing. Is there not a paradox to postulate an infinite in the past?
I think
infinite time in the past.
I mean, I'd be really interested to hear some more of the arguments of that kind, because in general, my feeling is that those are very much in a specific model for how you generate the next universe out of the previous universe, in which something is lost in every replication, and therefore you can't actually do this forever, and so that's a possibility. But I've also, I know of other theories that, to me, don't sound like they have that sense of running down. It's more of a true reset in every version, and so that's in those. I think that we still have the possibility of infinite regress.
This question about satisfaction and being dissatisfied with explanations really intrigues me, especially in a conference in science and philosophy. Explanations are things that satisfy our desire to know and understand. And an equation satisfies the desire of an experimental physicist or theoretical physicist to know and understand. The philosophical mind has an explanation and then wonders about that explanation in a sort of broader possibility space. It's a restless mind, not necessarily a dogmatic mind, but one that said, so what might be the explanation for this? And is that just a fundamental difference between physicists and philosophers, or is that a mindset that can be shared on both sides?
I'm thinking both sides, but say just a little bit. Say just a little bit more about the distinction that you're picturing. Say that one more time.
So the equation at the beginning. I'm just thinking this moment with Robert Lawrence Kuhn, where he said, so maybe someday we'll have this equation. You just said it again, and that would be satisfying for me.
Yeah.
And then I thought it wouldn't for some of us, right? I'd want to know. My philosopher's mind would say, is that a brute fact? Yeah. Or what else could we ask about it?
All right, so I will say that I can picture both feelings in myself, right? That I might find myself thinking, that's all we get. We get this descriptor of what the world is, and I would want to, and I in one picture of what we're trying to do, that would be satisfying. But I also very strongly feel the other that you're describing, which is the philosophical stance that, there's got to be more to talk about here. Yeah. And I think I would very strongly feel that as well. Yeah. I think that's probably the case for many on both sides. Yeah.
I wonder whether this fine-tuning debate is similar, because some people say, so the fundamental constants are the way they are, and this is a universe that's anthrophilic, right? It's a kind of universe that could or is likely to produce life. And some people say, all right, so those are brute facts. And others say, well, that begs for its own explanation. Is this just an incommensurability between kinds of minds, or can we bridge between them? So as a philosopher, I'm drawn toward the explanation, the search for an explanation. Why is it this way? Do physicists not share that at all?
No, I think they do, and I think that, and I certainly do, but myself. But I think that I have been in discussions with people where, people might begin with one take on it that they they perhaps were taught, and that left them feeling like, this is all we say and we stop here. And then you work with them and you discuss a little more and you say, but there's more of a question here that actually we want to try to figure out. And I think people do start to pick up that extra sense of curiosity of, okay, but that's not quite enough, right? I mean, this was, for example, the classic this debate that happened among the physicists about the interpretation of quantum mechanics, right? Where there's this one point was, well, we now know how to do the calculations, so shut up and just calculate. And then there's the other group that's saying, but what kind of world is this? And does this, should we consider multiple world interpretations? And once you start discussing different possible interpretations, is there something you could go measure? And of course, in some sense, that was a little bit what drove these Allen aspect type measurements to try to get to the bottom of, could there be a hidden variable floating around in the story? And apparently there's not. Apparently there's no. So that was an example.
So the quantum example is interesting. You didn't discuss it on an interview you once did on Must the Universe Contain Consciousness? But in Copenhagen in the early 1930s, that's where people's minds went. So we have phenomena that are observation dependent, measured or not measured, give you a different outcome, Schrödinger's cat and so forth. And then some people said, so consciousness of the observer, the measurement by an observer, changes the outcome of the physical world. So physics and some kind of theory of consciousness seem to be related here. Is that an example of where the two are drawn together by the nature of the things that we measure and find?
No, absolutely. And I think in the extreme case, I mean, if we really came to the conclusion that it was specifically conscious beings that was changing this physical event, that would be, I think, a huge change in our philosophical take and a huge discovery. My current read of the story is that there are lots of other things that are not conscious that also create the same effect, and so it doesn't actually do what we were kind of hoping. I mean, if we were trying to still get at consciousness, we were hoping that would be a way in. My current read is that it doesn't quite do enough for us in that respect, and it's a twig falling over is as capable as a conscious mind in triggering these the collapses of the wave functions. So therefore, I'm at this point I don't yet find that as the one that does it, but it's a very good example where, in principle, that if that were the case, that would be an amazing discovery, and it could have that implication.
So concerning the fine-tuning, you speak about this in Closer to Truth, but before you there was also the same question to Leonard Susskind, who is an atheist, and he answered, there's 4 possible answers. First, God, or a creator. Second, pure chance, not very credible. Of course, infinite number of multiverse, or what I call your answer. That means one day we will have a theory of everything. We'll explain exactly why the fine constant is this exactly this like this, okay? But my question is, Stephen Hawking in his book, and he was also an atheist, said, yes, but if we have a final theory, you can explain all the value of the fundamental constant. What gives the fire to the equation? I mean by this that I think you cannot escape the question of meaning with the solution number 4. I would say your solution to the fine-tuning. Like with the question number 1, we can also accept throw this away with the question of the multiverse. And multiverse we can speak after, but what is your opinion about this different solution of the fine-tuning?
And I probably should be clear that just in case it wasn't obvious, the topic that this came out of was a question about, is the universe, are there like fine-tuned things that we see in the equations that happen to also make it possible for us to be here, and is that not significant? Is that not meaningful? And of course, the range of ideas that we were just Jean is describing, include the possibility that that it was intentional in some sense, that these were put into the universe so that we would be here. Another is that it's just we just don't understand the physics very well yet. Once we understand it, we'll realize that, oh, what looked like fine-tuning just was some different process that was happening, and some other way in which the universe, is if we had the real picture, it wouldn't feel as dramatic. The one that the pair that many physicists are using nowadays is the ones that have to do with a multiverse, or the possibility that there are many, many, many ways that a universe could be, and in fact, maybe there are many, many, many different universes out there, and that the people who get to study universes happen to live in the ones that are fine-tuned enough that you get a chance for there to be a complex beings, and they have to be complex enough in the right kind of way so that you can look at the universe and have thoughts about it. So that's one of the other ones. Now, I should say that in that earlier conversation, I had described myself as open, particularly to the one in which once you really, really understand the theory and really understand the world, it doesn't feel like fine-tuning anymore. Actually, my feeling now, and I'm not sure whether I would have said the same then, is that although I think that's certainly a possibility, I'm actually relatively open to almost all of these possibilities. And the only thing that I'm a little worried about is that that even if you ended up concluding the very first one that it's intentional, it doesn't feel to me that it yet gets at the religious issue, because religion feels to me it needs much more than just a intentional creation of what we see around us. It needs that to be tied to a bunch of other moral, meaningful issues, because I would think it would be as likely that there are, super capable beings that can create simulated universes, and we happen to be living in one of those simulated universes. And then you have to ask, okay, but what creates those super intelligent beings or super capable beings? And to me, it only becomes interesting from a religious point of view if you have a way of tying that to true, meaning in life, morality, perhaps, and maybe other kinds of emotional connection. And by itself, that feels to me too mechanical. It doesn't. It's just one thing that happens,
No, you're absolutely right. We are speaking here about a creator of any type. It could be a student if a non-dimensional universe who make a PhD. But the question is that when we make the interview in Lindau, I ask you a very provocative question. I say, for the Occam razor say we have not to multiply entity for no reason. Is it not more in phase with the Occam razor to postulate one creator for this universe, any sort of creator, of course, not a monotheistic God, it could be anything, than an infinite number of parallel universes we cannot observe? So in Lindau, you answer to me, yes, you are right, but we cannot put this in the movie because you say you, and in the movie I don't appear, I'm the interviewer, so I was frustrated by your nice answer, but we cannot put this in the movie because in the movie there's no question and there's no you of the interviewer. So can you develop now for us the idea who is not in the movie?
And I guess now I'm allowed to use the word you because it's too late.
Not for us.
Right.
For us, we can.
No, but I do think that that I've been very reluctant to go to some of these including anthropic theories for very similar reasons. That of an Occam's razor argument that we really want to be pushed to have to consider 10 to the 500 universes, as some of the current theories are asking for us. Because it does seem to me that that's clearly out of the spirit of an Occam's. If anything's going to be out of the spirit of a simple thing, having decided that we can only explain this by imagining the 10 to the 500 other universes and that we're in one of them, that seems like it's the antithesis of Occam. Now, to be fair, if it turned out that that you could actually that your theory was big enough so that it actually started to capture the distribution of behaviors of those 10 to the 500 universes, and it made a very specific prediction that we could go look for, and that's what we found. I think we would have to take that over theory seriously. And there's something that almost looks like that, but it's a post-diction, unfortunately. It's not a prediction. which was that there is the question of why is the amount of dark energy, I guess the one we describe it, very small. It's only a part in 10 to the 120 of what you might have imagined in our theories naively. And there is an explanation, I guess, that I think it was maybe Weinberg who suggested it, that we're right at the very top of how strong could it be, how much of it could it be, without causing a universe to expand too fast for us complex beings to be here. And that it turns out that the number is just right near that amount was the argument. Now, the current measurements of dark energy of just last couple of years are starting to suggest that actually the dark energy behavior could be varying in time. And if that's true, then no matter how nice that post-argument, that the post-diction was, it would be irrelevant. We would now not take that as evidence for that argument. But it's an example of the kind of argument that you could imagine that with 10 to the 500 universes, somebody will be able to make a prediction for something that we don't already know the answer to. We go out and look for it, and we say, sure enough, that's the measurement. Then I would think that now Occam's razor may start pushing us more onto its side, because it's a falsifiable question that we've dealt with. But otherwise, I tend to be with you in, and I'm allowed to use the word you, in the starting point, which is that it's probably not the place to begin. The other thing is that there's been this idea that the anthropic explanations for things, where that you can explain parameters in the universe because you would say, if they weren't that way, we couldn't be here. And it feels to me like that's a slippery slope approach to doing science, because at any given moment, if you don't really understand things, it may be too easy to stop trying to figure them out, because you say, well, you know, the planets are orbiting the way they're orbiting because otherwise we couldn't be here. And you never bother to develop the theory of gravity or something like that, because you just stop a little bit too soon. So for my taste, I would rather save anthropic arguments of this kind, that it had to be that way so that we could be here. I would like to save them for very, very, very last resort. And by that, I mean after you've spent many, many generations with many, many new technological developments, doing many, many new experiments and tests, and still you can't figure something out, then maybe somebody might be open to that. But I don't think we're anywhere near that yet.
I tend to think that the science and the philosophy are going to run in parallel, that philosophers are unlikely to stay silent for many, many generations. And also the philosophical side of every individual is unlikely to stay silent. To ask those questions can help propel the science forward and also look at possibility spaces. So if it turns out that this one can't be explained, then what might be the case? And again, that's that hypothetical understanding of the relationship between the two.
I think I'm completely on board with that. I mean, the idea that you want to be, you want to drive a real willingness to try very difficult experiments and to try try out many, many different ideas to track down things, because we're driven by the curiosity of how does this really work, and this is not satisfying yet. And I think that is really what you want as progress for science.
So we're in our last minutes, and I just want to get to a theme and hear your views on it that's going to come up in the conversations today. And those are relations not just between science and philosophy, but science and religious philosophy. So science and religion. I'm sure it's a question you've thought about. I'm sure it's a question you've been asked about. But how do you generally respond to the question, what do you think are the relationships between science and the religious side of human beings?
I think here I find myself actually doing something very similar as to when we discussed consciousness, which is that I realize that religion is many, many things to many, many people. And that if we're going to ask, how does science relate to religion, we have to ask, how does it relate to each of those different things that religion does for people? And I know just maybe 4 to-do lists I don't do. Variety ways that religion plays a role that come to mind. I mean, one might be to understand the physical world that we see. Why does it look the way it does, and how does it work? That has been a role for religion. Another one is to give us our standards of morality and give us our shoulds and what do we want the world to be, or what do we want our behavior to be. That's clearly been a big role for religion. Another one is to provide a sense of meaning, of what's the point of our lives. Why are we here, and what do we want to feel at different points in our lives, such that it means something. It's not just arbitrary. A fourth one is related but different, which is it serves almost our emotional connection to the world that we live in, including our sense of comfort, that somehow this is the way it should be, or not. And I'd say those are all four very distinct things, and science could be interacting with any of them at any given moment. One of the typical reasons I think that many scientists have ended up in a position where they can't have a good discussion about religion is because they're feeling like if they start with one of these, the other three are all wrapped up together in the discussion before they get a chance to discuss it. So an example of this is I remember I got a phone call once. I picked up my desk and somebody asked me whether I would mind talking to them about whether it's possible that the speed of light has changed over the eons. And I thought for a second. I said, well, I'd be happy to talk to you about that, but let me just check first is the reason that you're interested because you're concerned about the fact that modern science is apparently giving us a much older universe than the Bible apparently is giving us, and if so, I just wanted to ask you first. I mean, your comfort in the world with the religious system that you live in is a crucial thing for you and for all of us. Whether or not we do it in one form of religion or another, and there's no point. I shouldn't be undercutting something that actually is giving you a sense of meaning and place in the world by some trivial arguments about what the speed of light cannot be doing. I think I happen to have some reasons to think that there's some evidence one way or another, but that's not the point. If the real question is what will makes you feel at home in the world, and so in some sense it's a different kind of a question that you're asking. Now, if we start asking, okay, but for me personally, how does science play with each of those four different elements that I just described? I would say that it certainly seems to me to be a more effective way of figuring out what the pieces of the physical world are around us, and that it usually, at its best, it will help us narrow in on what the questions will be, as we discussed about the origin of the universe, because eventually we'll get back to saying, okay, now we just have to explain why do we have this equation, if that was the best of it. So that feels like a more prosaic interaction with it.
I really like your distinction of the four and keeping them separate and knowing which conversation we're having at a given time. You mentioned a fifth in this conversation. I just want to make sure we have it on the record, which are questions where science gives a certain answer, and there's a question that can still be asked beyond the science, metaphysics, and that's the place where we sometimes engage in that why asking, the further question asking. That's a science and metaphysics relationship that might have a religious drive or not have a religious drive.
Oh, absolutely,
So
absolutely.
isn't that a fifth and separate one?
I think it's probably worth separating. I think I was picturing that as being part of the first one of describing the world, but I think that description included the meta. But I think you're right. It's helpful even to separate it out a little bit because it does have a slightly different conversation that goes in.
And hopefully we'll do a great job with all five today. Please join me in thanking Saul for a fantastic interview.